right, guys. We are not spending a lot of time talking today. We've got one formula to go through. It's best if you get it into your notes first, though. So I'm going to let you spend some time with this page. Get that copied into your notes, and then we will talk. Okay, so let's talk about what we're looking at here. Newton's law of cooling. You just poured yourself a cup of coffee, and you set it on the counter for 5 minutes. Started at what temperature? What temperature did it end up with at 5 minutes later? Took a baked potato out of the oven. When you took it out of the oven, it was a certain temperature. How long is it going to take it to get down to 100 degrees? We can use this Newton's law of cooling formula for questions like that, as we look at over time and temperature changing. So the things that you are seeing up here, the original T, this T at the beginning, is the temperature it's talking about. Okay, so at the end of that amount of time, that's the temperature. All of the T sub S's, which there are 2 of them, is the temperature of the air surrounding whatever our object is, because obviously that has an impact on the rate at which it is cooling, because a colder atmosphere, it's going to cool further, etc. T sub 0 talks about when the moment started, when at time is 0, at the very beginning, what was the original temperature of your object. K is going to be just some constant. And then T represents the amount of time that has passed. Sometimes that's what we're solving for. Sometimes we know that and we're solving for the temperature at the end. What we're going to see on this problem is kind of seeing this in a couple different ways and how can we utilize this in a complex manner. So let's look at a problem that involves this Newton's law of cooling. At 3:30 a.m., John P. Coroner arrived at a crime scene. He probed the body and determined that the body's temperature was 91.6 degrees. 20 minutes later, he took another reading and determined the body's temperature to be 88.3 degrees. He also noted the temperature of the room to be 72 degrees. Through all this, we should be able to figure out when the person died. So, questions that people have before we jump into this, so I don't want them to be distracting. Celsius versus Fahrenheit, be consistent. Okay, units of time, again, be consistent. Ours, it looks like we've got a time measurement in 20 minutes, and so I would do this in minutes, and then make sure at the end that I'm understanding that my time is done in minutes. Okay, so just be careful that you are consistent with your units. Like if they were to talk about an hour and 20 minutes, that we wouldn't do like 1 hour and 20 minutes, we'd do like 60 minutes and 20 minutes, right? Consistency along our units. That I can think of our information as like ordered pairs, where our independent variable is done in time. Our dependent variable then becomes our temperature after such amount of time. And they do say that when he walks in the room and probes the body right then, when he walks in, it was 91.6. So to start this problem, I'm actually going to let that be at time equals 0, right? Because that's right when he walked in the room was time equals 0. And at that time, the body was 91.6 degrees. Then we move over to time equals 20, and the body was 88.3 degrees. And also keeping in mind that the temperature of the room was 72 degrees. Okay, so as we look at that Newton's law of cooling, obviously T sub S we have 72. I know that 20 minutes later the body was 88.3 degrees, so the body is 88.3. That would be this one right here. If I plug in 20 right here, those two numbers correspond to each other, right? And what we can do is let the initial temperature be 91.6. So we've got this one, we knew the temperature of the room, which is everything but the constant, and that means that we can plug all of that in and solve that equation for K. So we can at least get that far. Okay, so putting those numbers in that we just talked about, 88.3 minus, that was 0.3, right? 0.3 minus 72 equals, we're letting our initial time when we walked in, time sub 0 be 91.6 minus 72, e raised to the negative k, and time is 20. And again, we picked time equals 20 because that's where we've got the 88.3 from. Any questions as to what I'm doing so far? So we're going to find K so we can eventually go back and find the temperature at any time, right? And or work our way backwards to when that temperature would have been for a normal body. So let's talk about our algebra here. 88.3 minus 72, what is that? Okay, and then I can do this part too, right? 91.6 minus 72. This is an exponential problem. So if we remind ourselves algebraically how I solve for an exponential problem, I get that exponential term, e to the negative 20k, by itself, and then flip to logarithmic, right? Logarithmic and exponential always solve each other. So I would divide by that 19.6. My exponential term is now by itself, so flip to logarithmic, which would become log base e, right, natural log, of 16.3, whatever 16.3 divided by 19.6 is. Yeah, that's fine. That's fine. So natural log of that fraction. And eventually solving for k, so I'm going to divide that by negative 20. And what are we getting for a constant here? Thank you. The question was not what is the cooling constant. Okay, so we now need to use that. It said, when did the person die? Okay, well, when the person dies, what would their temperature be at that time? What is the normal average human temperature? 98.6. So if I can work my way backwards, I want to know how long it took me to get from my 98.6 to like when I walked in and it was 91.6. What is that time difference, right? That's what I can now go back and do and say, okay, now I'm letting time sub 0 be time of death. How much time passed to get to the 91.6 now that I know all the rest of the unknowns in my equation? So I can take that K, so we can get this out of the way here, take that K and plug it into my equation. I want to know how long it takes me to get to a temperature of 91.6 in a room that's 72 degrees. If the body starts at 98.6, that would be our temperature at time sub 0. And our cooling constant is 0.009, so negative 0.009. And this time we're solving for time. We want to know how much time it takes to get this to be 91.6. So same thing we just did over here. Let's clean this up. We already talked about the 91.6 minus 72 would be, what, 19.6? 98.6 minus 72. 26.6. Same solving process that we just did, so I'm going to divide by that 26.6 to get the exponential term by itself. Flip to logarithmic, natural log of 19.6 over 26.6 equals negative 0.009. That's going to give me some ugly number in my calculator. Divide by negative 0.009. What are we getting for a time? Yeah? Okay. That's not a time. So discuss with your table partner how you would actually answer the question. It does not make sense if I said, when did the person die? They died at 33.907. That's not an answer. Give me an answer. Yeah, don't hurt yourself on this. Don't overthink it. Yeah, it's 33.9-ish minutes before we walked in at 3:30, right? So 30 minutes would be 3 o'clock. 3 more minutes, 2:57. So sometime between 2:56 and 2:57, person died. Questions? Not that I know of. All right, that should help you with number 30 on the assignment. Use that formula there. We'll make that problem make sense. You guys have a lot of jobs today. So I'm going to kind of highlight the jobs that you have. Some of them are this page. Ignore the homework packet at the top. This is just things that you need to have taken care of. Most of you have taken care of this one. I checked that on whatever day this week. Most of you also have taken care of this one as well. You were assigned this yesterday but told you did not have to have it done when you walked in here today, so that's from yesterday as well. If you have not done that, that needs to be done. 2 things that are not on the board that you need to also remember is that you have, now it is open, it was opened up at 9:15 this morning, and it will be open until midnight a week from today, is your multiple choice quiz on AP Classroom. And the last thing that you have is I'm going to hand back your quizzes, and you need to get your quiz reworks done. So that same form that we've had on all the last quizzes is that we will fill that out. I did rearrange the trays back there, so make sure you're paying attention to what you're putting it into as you are working on